Uh, my name is Sang-Wan Song. I'm the director of the SNU Center for Educational Research, and today we have a special event. We are hosting special guest lecture forum for internationally well-known scholar from Germany, from the University des Saarlandes, Saarland University. And the name of the today the speaker is, as you see, Rolf Hempelmann, Professor Rolf Hempelmann from Saarland. I am highly delighted to see our dear friend again. Yes, and also we are. I am also privileged to have him on our campus again. And before my colleague Professor Jung Dae-hong introduces our guest speaker's expertise, I'm going to just introduce today's speaker to you according to his curriculum vitae, short version. And Professor Hempelmann, he has a professorship, Professor Ordinarius for physical chemistry at Saarland University since 1993. And he is also co-founder of the Transfer Center for Nano Electrochemistry, and it's managing, and he's been managing. What is it? And he is a co-editor of the Journal of Physical Chemistry, and he received the Nernst Prize of the German Bunsen Society for Physical Chemistry for neutron scattering work on metal hydrogen systems, right? Good. And today we also learned that he is the vice president of the German Korean Society in Germany. It's a federal, it's a society on the federal level, right? Okay. So we are very honored to have you as our guest speaker today. And now I will introduce Dr. Jung Dae-hong.
안녕하세요. 정대영입니다. 제가 이제 롤프 햄펠만 교수님하고의 또 수년간의 친분과 또 교류를 통해 가지고 오늘 이렇게 우리 서울대 교정원 포럼에 모시게 됐습니다. 교수님은 전공으로 치면 화학자입니다. 화학자고 세부 전공으로 지금 물리학, 피지컬 케미스트리, 그리고 그 속에서도 일렉트로 케미스트리, 나노 케미스트리, 이런 다양한 분야에 굉장히 많은 연구 업적을 쌓으시고 뭐 퍼블리케이션도 굉장히 많습니다. 우리가 뭐 정량적으로 얘기하자면 사이테이션 수가 어마어마하게 높은 연구 업적들을 쌓고 계신데 이제 최근이 아니고 한 지금 한 10여 년 이상 관심을 가지고 계신 분야는 교육입니다. 그 컨텐트 기반의 과학자로서 과학의 어떤 연구실, 대학의 연구실, 기업의 연구실, 그 다음에 또는 어떤 회사의 국책 연구소의 연구실들이 중고등학교, 초중고 학생들한테 연구실의 일부를 오픈해가지고 그 과학 대중화, 그다음 관심들을 키워내기 위한 이제 일들을 하는데 그 일들의 이제 이름이 이제 우리는 스팀 교육, 뭐 융합 교육 이런 얘기를 많이 하는데 독일에서는 슐러 라보라고 해가지고 번역을 하면 스쿨 랩, 스쿨 레보레토리 뭐 이렇게 되는데 그런 어떤 이름 하에 그 과학 대중화 융합 교육에 이제 일들을 좀 해오고 계십니다. 그래서 오늘도 아마 그런 얘기를 주로 해주실 것 같습니다. 큰 박수로 롤프 햄펠만 교수님을 맞이해 주십시오. 환영합니다. 네.
Yeah, thank you very much for this very friendly introduction. It's a great pleasure to be here again after 3 years of Corona interruption. It was 3 years ago that I was here, I guess. And today I want to explain to you something about a German Schülerlabor scenery, out of school labs for school students, and what we are doing with Education for Sustainable Development. We do a special aspect, namely the STEM aspect of sustainable development. The starting point of what we are doing is 2,500 years ago. And this is this philosopher, and he already knew that it is very important to let the young people do something by themselves. You all know this statement. And this is the idea behind everything here. Young people learn best if they do something by themselves. And therefore, in Germany, Schülerlabor scenery started. And this is the development in the last 20 years. So there's a nice increase. And now we are here at 570 Schülerlabors in whole Germany. And I have to explain to you what does it mean, Schülerlabor. Hagyu Hak Seng Shilhom Shil. There are many out of school places to learn, like history museum or theater, and there's a subgroup of them, which is the out of school STEM places to learn science, technology, engineering, mathematics. And again, a subgroup is this Schülerlabor. And Schülerlabor is only out of school place can be called a Schülerlabor if it provides well-equipped laboratories, like you see here one. This is our new laboratory. If it provides authentic surroundings to the young people and thus also professional orientation. If it allows young people to perform the experiments by themselves, hands-on, this is very important. And if there is a regular offer, periodical offer, and regular does not mean just one time per year, that also would be regular, but it means at least 20 times per year, 20 because the year has 40 school weeks, and at least at half of them there should be something happening. This is a map of Germany, and all these Schülerlabors are distributed all over Germany, but not only Germany, also the neighboring German-speaking regions like Austria here, Switzerland, and Luxembourg. There are some Schülerlabors, and here you see many of them in our state, Saarland. Oh, this is. In both, it's one, yeah, here. In Italy, yeah, but it is German speaking, no? Yeah. German speaking. And so it is since about 25 years, more than 470 Schülerlabors. And here, look here, who are the carrier institutions? These are universities, 40%, private clubs like what I have now, no? It's about 13% research centers, 10% industrial enterprises, 10%, and many others. And these many here, you see here, Saarland University. Now I try whether it works. No. Oh, it works. But back. Okay. Oh. So you know this, no? The types and characteristics of learning. We have formal, non-formal, and informal learning. Formal learning is at school, and attendance is there must be attendance, but there can also be some out-of-school examples. Anyway, it is organized. And for instance, if a class visits a museum organized by the teacher, then it is formal learning. Then we have the non-formal learning. This is voluntary, out of school and free choice. And for instance, it's a summer school somewhere. So the child or the young person can voluntarily go to the summer school. But once he goes to the summer school first day, he also has to go there second day and third day. No? So there are some formal parts in it. And informal is just by accident. If you see something interesting in the TV, or if you visit a zoo, no, then you learn, of course, something. No, nothing is working. So for formal, non-formal, of course, the boundaries are fluent, and the Schülerlabors are inside this non-formal region, and they have a little bit of formal aspects, a little bit of informal aspects. And Schülerlabors, if you want to translate to English, you notice that there is no direct translation. So correct would be out of school hands-on labs for school students, but this is just too long. No? And if you say school labs, you think about the lab at the school, but it's out of school lab. And if you say student lab, then you think about university students and not school students. So therefore, Schülerlabor. Pupil, maybe. And you know, there are some words, German words made in different languages, like kindergarten building made it in the English language, but this work, no, Arbeit, made it from the Korean language into the Korean language. That's also possible, but there are only, you know, more examples than I. It's originally, yeah, in Germany, it's regular word. Yeah, I know. Yeah, that's other than in German. So this was about Schülerlabor scenery. Now something about sustainable development. There is this famous Brundtland report of the United Nations. And this says sustainable development is a development that satisfies the present generation's needs without jeopardizing the possibilities of our future generations to meet their own needs. And this is an important goal of our society today, and not only German society, countrywide. This is the goal. And you know, sustainable development has there's this three-column model. No? We have economy, it must pay off, otherwise people won't do it. Ecology and social issues is also some important, because people do not accept, they do not do it. So you must be convinced that it is useful and reasonable. These are only 3 columns, but Manfinger. Okay, this one now. If you want to implement sustainable development, the most important thing is Bildung. Bildung is a German word, and it is hard to translate, because education does not mean really the same thing. Education would be back translated Ausbildung. So you learn for a job, you learn all the skills of the job, but Bildung is more. And perfect, no? Yeah. If you do not know what is Bildung, you go to Wikipedia, no? Everybody does this, so Wikipedia gives this answer here. It means a German tradition of self-cultivation as related to the German for creation, image, shape, wherein philosophy and education are linked in a manner that refers to a process of both personal and cultural maturation. So if you know all the background and what the same thing means in other countries, intercultural and so on, that is Bildung. It is more than just education, but I stay with education, the term education, because otherwise it's a problem. So we need education for sustainable development, but this is not enough. Additionally, urgently needed is research and development in this field, because without development of new sustainable products, materials, processes, the transfer of the society into a sustainable society will not succeed. And therefore, and if we want to do that, we also need the corresponding education, and this we call STEM, sustainability education. And then we have this is the fourth column. Now we have 4 columns: scientific literacy, technology acceptance, as people don't accept, will not be successful, education for sustainable development, and environmental education. And here is a definition of STEM sustainability education: interdisciplinary knowledge on these issues, but also it promotes environmental awareness and sustainable attitudes. And this is important. And Schülerlabors are particularly suited to provide this and to bring this via the Schülerlabors and via school students as multipliers into the society. So, and I want to emphasize that STEM, sustainability education, is a transformative education. We do not only want to bring knowledge to the young people, we also want that they think about it and think about their behavior in terms of this new knowledge, and maybe hopefully change their behavior positively, and perhaps even choose a job later in this field. So this is transformative education. We do not only want to put knowledge into the young people, but also change their attitude. And then we come to another point. This is the dissemination of research achievements. And important technological achievements occur in an increasingly shorter time interval. We all know that, no? Development is very, very fast. And this has essential impact on our daily life. And this is now important. No? The progress in science and technology does not wait until it eventually makes into the official school curricula. That means into the formal sector of education. And there is the point where the Schülerlabors come into action, because Schülerlabors, as a non-formal education entities, we act as a bridge between research and school. And we have, you see, like you see, and Schülerlabors are locations of educational freedom. That means we can try out new things. No, school cannot do that because they must follow their curriculum. We can just do what we think is nice and helpful, and we can systematically probe that. And here you see the bridge function between research and school, and here's also then society. In research, we must, like university, we have front of science, that means subject-specific things. And we have also subject-specific didactics. And I give one example for this here, and one example for this. So the example for the scientific part is ionic liquids. This is our molten salts, which are liquid at room temperature, some complex chemistry. And they have, these are new, they exist, really exist since about 20 or 25 years only. So the present teachers in school, chemistry teachers in school, they did not learn that at university because it was not there 20 years ago. Ionic liquids have many applications, meanwhile, in process optimization, recycling, in energy storage, power generation or energy technology, and in renewable resources like pulping or processing. So many applications. So it's an important class of materials. And usually what scientists do, they do research, they find something new, then they write a paper, and we wrote a lot of papers on ionic liquids. And if they are even thinking about applications, they file patents. Actually, we filed 2 patents on ionic liquids. And then the next step would be upscaling to the pilot scale and industrial process. But this happens very rarely, no? Only for a few new things. But we now did a different thing. We did not an upscaling, but the downscaling. And the downscaling down to the level of school. And so we developed school experiments, like some of them are listed here. And we wrote a book about these experiments, but we wrote this in German language because we want to address German chemistry teachers, and German chemistry teachers, they want to have German language. They are not so keen on English language. I guess other countries' teachers also want that in their own language. So we wrote this book here. But we also did the translation into Romanian language, which is a little bit of strange, but I have some connections to Romania. And now also, since a couple of years already in progress, is translation into Korean or into Greek or English. English, actually, we have translated, but I did not find a publisher to edit the book. So, and this also be paid by ourselves, not a book publisher. So, and then the second example, the example on didactics, and there I show you something about language sensitivity, and this we did in collaboration with Professor Stephanie Haberzettel, and you are closely collaborating with her, right? And we wrote something about educational science in the language of educational science, and this language is different from everyday language, and there's the educational science distinguishes here 4 fields of action: empirical approach to language, which we do not do as a subject scientist, receptive competence and productive skills, and language education competences in teacher education. So we are doing only these 2 points. And here we had the master thesis in receptive competences, and this is kind of defensive strategy. That means you avoid language. Some young people have problems with language. They do not understand, if they read the instructions, they do not understand what it means. In Germany, these are children with migrational background. We have quite a number of them, but not only, also some German young people have problems to understand the meaning of what is written. So the remedy would be to avoid complicated sentences and make it very simple. And this we have also published. Here's the publication. And you see Stephanie Haberzettel is first author, so she helped us a lot within that field. And the other thing is in offensive strategy. That means training of the subject-specific technical language. And also that we did, but were not able to publish this. You can practice written language also in the Schülerlabor when writing the protocols. And now after this was the first part of my talk today, and now second part, what I am personally doing in this field right now. And I'm operating a Schülerlabor on this area here, which is Alte Schmelz area, old melt. This was in previous iron works, iron factory. So these are the old buildings from the iron factory. And now it is a historical monument. This, for instance, here, this building here is the oldest industrial building in Saarland from 1765. And at that time, they were not able to build, the Germans were not able to build big halls. So what they could is church architecture. They know church architecture. So this is built in church architecture, but it has never been a church. Anyway, here have been bells, but this is in order to indicate to the workers which time is now, because at that time they did not have a watch by themselves. So, and this is based, this ironwork is based on coal. And we have in St. Ingbert in my town, we had a coal mine, now it is out of operation, but it is kind of museum, so you can enter the coal mine. And we do this from time to time with the young persons, like you see here. And also we have, this is how it looks inside. And we have iron ore. So we have here different kinds of iron ore. This is brown iron ore, FeOOH, and the origin is local. That means in my garden, if I dig in my garden, I find something. No? It's everywhere in our area. There's sandstone. In the sandstone, there are layers of iron ore, like you see. So this I found by myself. No? And in recent days, they walked into the forest and looked for some iron ore. The content is low, no? So nowadays it doesn't make any sense. Then we have also from Saarland a different iron ore, which iron carbonate. And these two iron ore were used in this iron factory. And nowadays, the steel company, they use high value iron ore, which comes from Australia, from Brasilia, or wherever. So, and this is this iron factory about 100 years ago. This was the largest expansion of it. You can see here some historical buildings which still exist. Like this one is the landmark of the whole thing. And if you look at this building, this has been still exists, but has been renovated. And now it looks like this. And this is our Schülerforschungs- und Technikzentrum, SFTZ, Youngsters Research and Technology Laboratory. And what we are doing in this building is we have a biology lab, a chemistry lab. We do physics in these labs. We have rooms for mathematics and informatics, and we have rooms for mechatronics, electrochemistry, and metallurgy. These are school subjects where we support the schools, but this is beyond, goes beyond school. So we also do something which cannot be done at school. And this shows you our chemistry lab. So the expert will see that it is pretty expensive, costs a lot of money. And I must emphasize, this is not university, not government, no? It's private lab. We are a club, not for profit organization. And this is, as I said, chemistry, fume hoods and central gas supply. Here you have the gas access at every place. So high level, like university level. And this is our biology lab. Biologists like to do microscopy. So we have enough microscope for them. This is a room for informatics courses. Informatics is maybe computer science. No? Informatics is not a good word in English. In German, it's Informatik, computer science. Yeah, so computer science course. Or here we have mechatronics course. And now from time to time, we get important visitors. We have important visitors. So this here is the general consul of the Korean embassy in Germany. And this is the science attaché, Korean science attaché. So they come to us and have a look. And this is the director of KIST Europe at our campus. And they come to us and have a look about why do they come? Because we had Korean kids in our lab. And they got instructions in Korean language even. But this is due because here we have an employee from KIST Europe and he also from KIST Europe. And these young people, they supervise the children during doing experiments. We have different countries there, no? And now I show you kids from another country, and these are kids from Ukraine. This is there was a first wave of refugees from Ukraine in Europe and also in Germany, and these are mainly refugees from the Kiev area. So there was a newspaper. This is important event. No? So newspaper report, but they wrote wrong. No? They are not from Kharkiv. They are from Kiev region. And that's what the newspaper wrote. Maybe you can read yourself. And now these people from the Kiev region, they are going back to Ukraine. And now we have a second wave in Germany, and the second wave comes from East Ukraine. So we are running out of space for living space for them. And we also do some fun for them, of course. No? And it's amazing, they behave just like normal kids. They make jokes and so on. So now I explain the context of what we are doing. So we have these subject areas in our institution. And here we have the context to the cultural industrial surrounding. So what we are doing is sustainable or green chemistry, water and soil analysis, ecological biology, and mechatronics. And this is closely connected to the climate topics of the UNESCO Biosphere Reserve in our surrounding. So we are connecting to the surrounding. This is metallurgy. And there we are connected to the history of our site, of our location, but also to the future of the steel industry. And I come back to this in a minute. So this fits very well to us, no? To our system location, our history. And then we do electrochemistry and hydrogen. This is my subject. And this is, of course, e-mobility, no? Important in all countries, also in Korea now. So, and we are prepare young people come to us as whole classes, but also they come in order to research for some science competitions. Now we have different science competitions like here also. And so this is a biology project, development of anti-mold agents. Or this is, now I come to a metallurgy project, and this is the old steel. No? You probably know this thermit process, or you don't know. So you mix iron oxide and aluminum, and then you ignite. No? And now let's say 5 seconds later, it looks like this. No? And then we produce here temperature of more than 1,500 centigrade. And the iron oxide is reduced by the aluminum to iron, liquid iron. It drops down to the bottom. Here is the liquid iron now. but this vessel did not survive. So we can produce a small amount of liquid iron. But this is the old way to do it, no? And now the new way is reduction by hydrogen. And so we have this little device here where we put iron ore here in the furnace. This is this iron ore from this steel company into the furnace and put hydrogen over it, and then reduce the iron oxide to iron. And this is called directly reduced iron. And by the way, this is my granddaughter. And this is the prime minister. Now we have a new one, the previous prime minister of Saarland. So he has visited us, and I practiced with her several times what she has to tell him. And so now that's reduced to iron foam, and iron foam is then pressed to tablet, and then we put it into a arc furnace, laboratory arc furnace. Here's the arc, and then we get green steel. So we are ahead of our industry now. No? Our steel industry in Saarland wants to start no? With green steel in 2026 or so. No? But what means start? If after it takes about 20 years, and it takes a huge amount of investment money, like €1 billion. And then finally it will be like this. We get electricity from renewable sources. Then water electrolysis produces hydrogen. The hydrogen reduces the iron ore. And this is then called directly reduced iron, but it is without carbon, no? Because there's no carbon up to now. So it needs some carbon, and this is the arc furnace in big scale. And this is operated by carbon electrodes. So from the carbon electrodes, you get some carbon into the iron, and then you get green steel, and you can do something with it. This is the future. And we in our laboratory, we are 10 or 20 years before this future now. And therefore, the steel company Saar Steel, they send their young people to us, because the young people which now get an education in the factory, now there is not yet this green steel production, but these young people will experience the transition from the traditional method to the new method. And so within their education, they should have a look on this process, and this they can do in our lab. Or here now electrochemistry, but here we have a simple sodium-ion battery, very simple one, you see here. And we can demonstrate that this thing can produce 3.5 volt, no, which is much more than you can produce by an aqueous electrolyte. This is an ionic liquid in here. Here you see it. And in this way, we get the access to the future of the e-mobility. And the future is the life cycles of the lithium-ion battery I show you here. So it starts with the raw materials. Then you need cell or electrochemistry and electrochemistry. The next step is the fabrication of electrodes. Next step is the fabrication of cells. Then the assembly of modules, assembly of batteries, mounting into the vehicle, taken into operation, phase of use. After it is not useful in the car anymore, it can have a second life. And at the end, there is recycling. So, and we have competences in the blue fields. And here you see how, and this is a part of circular economy. The new lithium-ion factories, they should produce the batteries in such a way that they can be more easily recycled afterwards. And here you see a scheme of circular economy, a little bit larger here. So it is characterized by 5 R's: reuse, repurpose, repair, refurbish, remanufacture. 5 R's is typical for that. And so if this is finished, Then you come to the recycling. You can recycle it as basic chemicals. In the case of lithium-ion battery, that would be the lithium has value and the cobalt has value. Or you can maybe recycle as a material. So maybe you can recycle lithium cobalt oxide directly, then you do not need to chemical manufacture it again. Or you can really a product manufacture and then get into a circular economy. So, and with this, I start with my conclusion. So sustainable development can best be implemented in a society through education. And this has to start with young people, of course. And the young people must be encouraged to behave sustainably. For instance, to use porcelain cups for the coffee instead of paper cups, or paper bags instead of plastic bags, and so on. And in our view, this is very important, but this is a matter of formal educational institutions like kindergarten or school. Our challenge, our ambition is more. No? As a non-formal entity, we want to go beyond that. So we want to give the children and young people insight in new sustainable materials and technical processes. That means we want to extend this education for sustainable development into a STEM, sustainability education. And I can say that the transformation of the society towards a sustainable society can succeed only with innovations, not only with just behavior. And we address with this, you probably know, or certainly know, the Global UNESCO Sustainable Development Goals, SDGs. And we address SDG number 4, which is quality education, SDG number 7, which is affordable and clean energy, and SDG number 13, which is climate action. So in the form of age-appropriate experiments, we want to enable young people to take a look into the decarbonized future of the region, not only of the region, also of the country and even beyond, in line with the EU's Green Deal. And in this way, the young people can draw conclusions about their future behavior in the sense of sustainable resource and climate-friendly behavior, and we want to motivate them to do so. And with this, I want to thank you for your attention.
Thank you so much for your innovation. Wonderful innovation. Thank you. Okay, do you have questions or comments? And we also have participants online. Or do you have if the participants online, if you have a question, you can send your questions or comments into the chat box. Just go over the topic.
So I can answer the first question. And the first question is, I expected the question, how do you finance that? No? Where comes the money from? I was prepared for that question. So this it is. So the building, this was 3.3 million euro. And this was covered by our town. No? This is the little town where I live. Of course, they got subsidies from some programs, from the EU program and so on. So, but anyway, 3.3 million, this is more money than our university ever spent on Schülerlabors. And this is non-university. And we have one permanent position, and this is paid 50% by our town and 50% by the county. Otherwise, we only work with volunteers. Also, we have honorary people, so they get, for each hour, they get some money. So the career is, and very important, I forgot, we have one deputy teacher. So our Ministry of Education and Culture has deputed one teacher for one day to us. So on Wednesday, this teacher is not working in school, but is working in our lab, but gets his usual salary. One day only. Up to now, I want to get more, but first we have to do something. One day per week, but anyway, this is very helpful. So the Career Association is a club, and this club pays scientific and technical equipment. So this building is only this fixed equipment like fume hoods and so. This is fixed, this is included in this sum, but all the glassware and power supplies and whatever, no, this is covered by this club. We have 2 lab leaders, which we pay hour by hour, and we have 4 students from the university with helpers also get some money, but otherwise the people are working while volunteering. Like me, no, I don't get any money from this. On contrary, I have to put in some money from time to time. Donation, yeah. So we got the Zasta company, which is a big steel company in Saarland. They give us money. There are some foundations and so on. And we have a little bit of third-party funding. It must become better. And sometimes we get kind of orders that we have to organize a summer school or something like that. And then we get some money. And this is how we finance the whole thing. So once again, not non-university, not government. Yeah. Yeah, as I said, 40% are universities, they have university money, but there are also 13% private, they do similar. And then there are big companies, they have money, and big research institutes also has money, but there are also other private institutions. Yeah, that's still operating. My successor, I don't understood your introduction, but I'm in retirement now. What did you say that? I don't know. So I'm in retirement now, and my successor operates a nanobiolab Schülerlabor, which I have built up at the university. So it goes on. And this guy, he thinks we are a competitor for him. But this is, of course, bad. We do not want to compete with university. Very bad thing. We must avoid that. Yeah, it's 12 kilometers. So it's near, yeah. And actually, in fact, it needs help from the university, because it's a chemical laboratory we produce chemical waste, and how to get rid of chemical waste, it would be very, very expensive, but instead of, we put it into the university, So we need the university. Yeah. We are operating in 3 operation modes. One is classical Schülerlabor, and then a whole class from school comes with the teacher, and they learn. We do not want to teach the students, the school students. They learn in school, and what they have learned, they can do they can do experiments with us. So for instance, if they learn alkanes in school, then they have an experiment for alkanes, and the instruction is very simple. No? It only say, given are 3 different alkanes, find out what is what. And then the kids come and they think, what did we learn in school last week? And then they have an idea how to solve this problem experimentally, and the equipment is lying on the desk. No? And of course, and this needs a number of supervisors to help them. No? But if they go a wrong way, we let them go for a while, because it's in life, in real research, also sometimes people go a wrong way, and after some time they recognize, oh, something is wrong, and they find out the right way, and this is much more instructive than you would tell them immediately what they should do. I cannot. Yeah, they can go to that. If the kids have heard about us, they can go to their teacher and say, "Oh, Mr. Teacher, we want to go there. Please organize something." And then the teacher calls us, and then he gets a schedule appointment. Then he come with his class. And up to now, we are for 1 day per week. We are, let's say, 70–80% occupied. We have some space still. We could have more, but this is only the 2nd year of operation. Last year was our 1st year, but this was still COVID year. No? So we had something like 800 Schülerlabor visits. And this year, up to now, we have 1,500, and we want to reach 2,000 in this year, next year 3,000, and so on. We are in the process of taking the whole thing into operation. Yeah, sure. Yeah, they can. There are also a list of the experiments, but only the title of the experiment, not in detail, because if the kids come into the lab and you say you should solve this problem, then immediately they take out their smartphone and look for a solution. So solution is not in the internet. Yeah, there is. In fact, there is a little bit. There is some kind of competition, right? But it depends. The kids come to this only if the way it takes less than 1 hour. If they need more than 1 hour to go there, it doesn't make sense. No? 2 hour first, 1 hour way, then 2 hours experiment, 1 hour back. Then it doesn't make sense. So it must be short distance, and so we are regionally limited. So in fact, those kids which come from the west side of university, they will come to us. Yeah. So there will be less at the university. Yeah. But on the other hand, what we are doing is we want to encourage the people to do a science study. No? So this is in the sense of the university. We help the university. And the young people, they are. Yeah, this is a question which very often comes. Now, how many of those people, those young students, visitors here, afterwards make a university study? And I cannot answer this question because this is a couple of years later. And within this couple of years, a lot of things happen, which also has influence on the kids. No? So we cannot have a comparison group which is without influence and one group which has the influence. We cannot. So we don't know what happens in between, what influence is in between. So I cannot answer that question.
At the University of Zealand, I remember that I saw some students, and some of them wrote their thesis.
Yeah. Yes, right. Yeah.
Then these assistants that you have,
yeah. This is my aim in the future. Right now, they're coming for us in order to get some money. I mean, every student wants to get some money. Yeah. And this is better than being than sitting in a supermarket on the cash. No? It's better. Instead of that, they should better do work here. So we are not that far that we can do thesis work here. Oh, it is pretty popular. Essentially, all universities have something like this. The university has to do teaching and research, but they also have to do a third thing that means they have to take care of the society. You know? And this is part of this third task of universities. They must be a cultural center for the town. No? University must be cultural center for the town. Many of my university colleagues do not realize this third task which they have, and this belongs to this third part. So every university, in one or other way, every university does it, and well, it is popular. Young people come, no? You know, they have to care. University have to take care also of the community. Yeah.
How it looks like the information students can search.
Yeah, maybe can we go to internet here? Oh, you can enter here. Yes. Main campus is written. No, I. Yeah, campus is slash. And now capital letters. Yeah. Oh, this is our homepage now. And we have different departments like SFTZ. This is not working. SFTZ is our department. Then we have here practical courses for whole classes. And there we have a calendar external. They have a calendar where they can book something. And here we have portfolio of our experiments. So we have different experiments. It is for Sachkunde is for primary school. This is for NW is Navi. It's for natural science. This is for 5th, 6th, and 7th grade. And then we have chemistry, secondary Stufe 1. This is all this kind of experiments here, which we can do. This is from chemistry or from electrochemistry or from biology. And then we have for the older, more advanced students, we have something here, and this is not yet developed. We are in the process of developing this portfolio of experiments. And this is where people can book one. So it's on the internet. You can look up, one can look up there. And this shows you here that we have also open use workshop, and we have a science forum. So we have different things, not only Schülerforschungszentrum, different things. And by the way, this is my Zhongli Zhao. So this is A-mobility. Thank you very much for your attendance.
줌으로 참석해 주신 분들 감사합니다.